All right, so the basis of limits at infinity of rational functions is if x approaches infinity of 1 over x. This, as this gets x gets very, very large, this approaches 0. And this is a key concept that we're going to use with this. So if I go ahead and take this limit as x approaches infinity of 3x squared plus x plus 1 all over x squared plus 1. What we want to do is break this up. And how we're going to break that up is I'm going to take each of these pieces in the numerator and denominator and examine them. But first, I'm going to take whatever the highest exponent is and multiply all of these by 1 over x squared. Same thing here. When I do that, I'm left with the limit as x approaches infinity of 3x squared over x squared plus x over x squared plus 1 over x squared, all divided by x squared over x squared plus 1 over x squared. Now, how does that help us? Well, first let's simplify it. And now I'm left with the limit as x approaches infinity of 3 plus 1 over x plus 1 over x squared all over 1 plus 1 over x squared. Now, what happens here is 1 over x squared, and 1 over x squared. All of those, as x gets very, very large, this approaches. So once I know that, this just becomes the limit as x approaches infinity of 3 over 1. So that now is just equal to 3. So let's take the limit as x approaches infinity of 10x over x squared plus 5 plus 3. Now, same process here. I'm going to multiply this by 1 over the highest power in the numerator and the denominator. When I do that, I get the limit as x approaches infinity of 10x over x squared all over x squared plus 5 over x squared plus 3. So in the numerator, I am just left with 10 over x. And again, this is as it goes towards infinity, over 1 plus 5 over x squared plus 3. Now, this goes to 0. This goes to 0. So as the limit as x approaches infinity, I have 0 over 1 plus 3. Remember, 0 over 1 is just equal to 0, so this entire limit is just equal to 3. Let's take a look at a couple that are in a different format. All right, so the only thing different with this is that I have x to the negative 5th power. So this just means I have to change that to x over 10 over x to the 5th plus 7x. So the limit as x goes to infinity of this becomes 0. So this is, and then 7x as x gets arbitrarily large becomes infinity. Now, they are not all that easy. Sometimes I have problems that have square roots in them. So let's look at the limit as x approaches infinity of 6x squared over 4x squared plus the square root plus 16x to the fourth plus x squared. All right, so I know this looks a lot more complicated, but it really isn't. We have to remember we're still going to follow that same idea of multiplying both the numerator and the denominator by 1 over whatever the highest power is. Highest power still being here. We just have to recognize that when we do this with the square root, we need some special techniques. All right, so how am I going to do this in the numerator? So let's just first do a really quick review. When you go through and I have the square root of x, and if I wanted to multiply this times the cubed root of x, I couldn't do this because they don't have the same denominators. This is written as 1/2 times x to the 1/3. And the rule is when you multiply, you add exponents. So you can't do anything unless they have a common denominator. So that's what I need to have here. I need to somehow take 1 over x squared and multiply it times the square root of 16x to the fourth plus x squared. Now, what I can do is change that to a fractional power, which is 16x to the fourth plus x squared. This is all to the 1/2. Now, what I want to do with this is multiply 1 over x squared to the 2 over 2 power. And I want to break that 1 over x squared, and I'm going to break that 2 over 2 up. I'm going to square the inside of this, and then on the outside take that 1/2 power, which now gives me 1 over x to the fourth, all raised to the 1/2 power times 16x to the fourth plus x squared to the 1/2 power. Now I can go through and multiply those together. They all still have a big bracket on the outside of 1/2. And the reason I can do this is because both of these now have an exponent of 1/2 on the outside. So now inside here, I get 16x to the fourth over x to the fourth plus x squared over x to the fourth, which is equal to 16 plus 1 over x squared. So let's go ahead and bring that back up to where we need it. It's 16 plus 1 over x squared. So now I know that this is the limit as x approaches 0 of 6x squared. I divided that by x squared. And in the denominator, same thing, 4x squared over x squared, and I used the result that I had from the bottom, which was 16 plus 1 over x squared. And remember, this was all to the 1/2 power or the square root. So from here, the x squareds cancel in the numerator, so now I have the limit as x approaches infinity of 6 all over 4. I'm going to turn this back into the square root. that is 16, and that 1 over x squared also approaches 0. So now I just have the limit as x approaches infinity of 6 over 4 plus 4, which is equal to 6 over 8, or 3/4.